Hello, Bill Newland. Some of you have met me. I've been coming here for a little while now. I'm a software dev, developing software since the late Cretaceous period. And I'm going to talk a bit tonight about something called vertical slice architecture. Got it, no onions, no tears. You'll see why in a moment. But we're going to talk broadly about that. Just a bit of a disclaimer before I start. I'm not going to talk about microservices. There may be some similarities with what I say on microservices, but this isn't about that. This is about smaller level projects, not enterprise level stuff we would do. We might present to a client that's small scale, traditional websites, that sort of thing. But it's about a way of architecting them that is slightly different and avoids some of the pitfalls that traditional development can give. So, I'm going to start with a bit of history. I'm sure all of you know this. We're going to talk about layers here, which hence the cake. I love a bit of cake. So when I started in computing, as I say, a long time ago, we tended to talk about three layers. You talk about UI layer, user interface layer, the business layer, where all the logic happened, where the meat of the product was, and then the database at the bottom. This was traditional way of doing it later, but we might have this over a distributed network, or we might have it just locally. But those were our three basic layers. That, at some point, transferred into the N-tier architecture, which we're more commonly known as today, which basically we added a data access layer in there. And we tried to isolate our database from the main layer. And I was always taught when we were doing this that the reason we do this is so that if we wanted to, for instance, change the database we were using, we could take the database off and put a database on. So we could change from SQL Server to Oracle or something like that. Never actually done that in all my career. Never ever have I changed a database from one to another. So it seems like an odd thing to actually want to do, but apparently it was the way we did it. But the problem with this is we end up with tight coupling between the layers. So it doesn't have to be done like this, but the database relies upon the business layer relies upon the data layer, and they're all interconnected. And we can't change the different layers, really, without affecting the others. So obviously, this creates some overhead and some problems with maintaining and extending our systems. So, we came up with a new idea. We came up with our onion architecture. This was popularised, it came around about the same time as domain-driven design. It's not quite the same thing, but it allowed us to separate our concerns in a slightly different way. So we started off in the middle of our onion with the domain model, where we define our domain, our domain entity, and how we worked. And then we'd surround that with some domain services to interact with that domain model, and then some application services around that, which would interact with the domain service, and the UI around the outside, and also some infrastructure and some tests. Now, the main advantage of this model, is direction of dependency. So, the domain model, everything only can interact with going into the center. So the UI can only interact with the application service. The application service can only interact with the domain service goes into the domain model. So we're inverting our dependency here. If anybody's come across dependency inversion, you'll sort of see what I'm talking about. So we have our services are defined by interfaces. And so as long as we understand the interface doesn't change, then we can change the layers independently. So we interact, the UI interacts with it goes down into the middle through services, through interfaces. So I'm trying to compress this quite a lot at the moment. Which reduces our coupling. So we are only coupled with the layer inside it. So we're not coupling. We can change our domain model without changing our UI, and we can change our UI without changing the domain model, as long as our interfaces remain the same. So we can change that implementation. But the problem is still, a single change may still affect every layer. So if we got we want to add a new field, that goes right the way down to the database, which isn't actually domain model, but right the way down to domain entity level. We have to change the domain. We have to change the domain model. We may have to change the services around it until we get up to the UI. So we're still affecting everything. Our coupling is different and is better, but we're still, a single change can affect the whole thing. So why is this a problem? When we change something, when we change our data entity to add its extra field, we then have to change all the other things. So we're changing a whole host of interrelated but not necessarily the same thing. Now, well, that's fine if you're working on your own, or at least it's not fine, but it's not too bad if you're working on your own, because your changes, you theoretically know what your changes do to other bits of your own code. Yeah, I'm sure you're all interdependency and all that. When you've got lots of people working on a project, or a few people working on a project, that becomes harder. Because it means if I change the application, if I'm changing the application services and you're changing the application services and somebody else is changing the application services, we may interfere with one another and we end up with merge conflicts and all sorts of horribleness within Git or whatever your chosen repo is. So it's hard to test because again we're trying to test all of those different layers. When we make a change that ripples across our services, we are having to test all those different things, and we end up with a more complex system. So what we're trying to do here, what I'm trying to talk about, is a way of thinking about this in a slightly different way. We're used to talking about separation of concerns, the idea of separating what we do based upon a broad abstract. So whether something's data related, whether something's business logic related. What I think we should be talking about is something slightly different. So I'm getting ahead of myself. Sorry. Thought comes not looking at that. I'm just going to give a quick scenario to show what I mean. Okay, so we've got a customer who makes a loan application in the bank. Okay, so the loan application checks credit score. It's not okay, so the loan is rejected, or it is okay, loan is approved, and the money is transferred to our customer. So that's quite a simple scenario, isn't it? I mean, we're just talking about something the banks do. I mean, obviously I've massively simplified this process here. Massively simplified. But the point is, this is a linear progression. This is a single thing. We're talking about making a customer loan application. So, again, massively simplified, but I've only talked about three of the layers here. But let's see what we do when we do apply for a loan. Now we've got all these different service objects that relate to our domain entities, and so we've got a customer entity, an account entity, a loan entity, etc., and services that interact with all this. So we do a loan, and all of a sudden we can see that we're touching an awful lot of those services. Because we're reusing stuff, so we have to evaluate the loan, we have to get the credit score, we have to approve the loan, we have to deposit money, update the loan book, and so on. So we've got all these different things happening in different layers, and within those layers, within different service objects. So we are creating quite a lot of cohesion, quite a lot of coupling between those systems. So what's alternative? So what we're talking about is these horizontal layers, horizontal slices, if you like. So what I'm going to talk about is vertical slices. So we stop thinking about separating on the basis of our layers. Stop thinking about separating by UI layer, business layer, and so on. And instead of that, we stop thinking about objects in that sense. So, and I was taught object-oriented programming again a long time ago. We talk about, we think of a car, and a car has wheels, and a car drives along the road, and this is our object, and this is the thing we define. But if we stop thinking about objects in that sense, and what we start thinking about is what actually we do, the functions and the features that we're doing, then we can talk about cohesion in different ways. So rather than talking about our layer this way, our layers, our tiers, we talk about slices. So when we talk about opening an account, we're talking about creating a function, creating an object that does that one thing. This is why I said there's a microservices hint in there. So we're doing one thing here, we're opening an account. We do a balance inquiry, we can do a loan application, and we're cutting across all those layers each time. And these are distinct things. They're not separate. These do not call out. They are entities in their own right. So each of our layers, each of our features becomes an entity rather than our functional layers. And that's because we, sorry, I put on the axis of change, because the things that change within our system don't tend to be these layers. The things that change in our system are these things. So if we wanted to change the way that a loan application works, in this system, we can do that without touching balance inquiry or how we open an account. They're separate things. So if we collapse the model for a moment, and we talk about the way that I would architect the system. So we're now doing the same thing. I'm now going to let this run about our loan application. So this is our object here, our loan application object, and everything that we do is within that object. So we may do things, except where we're going out, either to an outside organisation like the credit agency, or to the database. We don't say, oh, okay, we've got balance inquiry over here. Actually, we've got to get customer data. I know we've got our customer object. We'll just inquire from our customer object everything about that customer. Instead of that, we're not saying that at all. We're just going to go straight to the database. And we're going to say we'll need some information there. And this may smack a bit of monolithic programming, but what we're trying to do is we're trying to encapsulate a user action, encapsulate a feature, so that if I want to change this loan application, it doesn't matter what I do in any other area. This in itself stays the same. And if I want to add a new thing, so I don't know, mortgage application, rather than a loan application, I create another feature that does a similar thing, but does it separately, which means that if I then change my loan application, I don't accidentally change my mortgage application. What we're trying to do here is create a situation where we have our features encapsulated in particular, within a particular object. Sorry, that was just in case the loan got rejected, obviously. But we say, so we've got this thing, and this gives us I'm going to go click ahead here and come back to that, just because I want that image up there. And you can see this gives us a fairly standard setup. We have an input, which was the loan application, and we have an output, which is whether it's rejected or succeeded. It may do other things in the meantime, but our basic process from a user perspective is this. Again, I'm going to jump forward and I'll come back. No, I'm not. Actually, I will come back because I wanted to do this. Sorry, I'm reordering my slides on the fly here. So, we have our different, so here's our bank again, our bank user interface, and we can see what we're talking about here. So if we press a button in here, that sparks up a whole process, an object that sits within our object, and we have an input since that, a process and an output. The way that we do this, again, we're trying to, I shall come back to that, sorry, no, I'll come back to that. So let's go back again, I just wanted to show you that screen. So, we have our input, our process and our output. Every action has its own class, own object, doesn't matter, module, doesn't matter. So, and we keep it contained, we keep our stuff contained within that object. Reuse is not your friend. When I was starting again, starting in computer programming, We were told a lot. We were talked a lot to about reuse. Build your libraries. Make sure you can reuse things. This is the way we'll lessen the amount of programming by having these libraries. And what I tend to find, I don't know if it's the same to you, but we end up with these colossal objects that do all sorts of things. Everything becomes a Swiss Army knife if you're not careful. So we have a customer object, and when we ask for our customer data, we think, oh well, we've got a single, we're going to keep on asking for our customer data, so let's have a function that's get customer data, that returns our customer data. The trouble is, the customer has a lot of data about it. So what we end up doing, if we're not careful, is we get loads and loads and loads of data about the client. You know, there's that old thing about object-oriented programming. I ask for a banana, I don't just get the banana, I get the gorilla holding the banana and the jungle that the gorilla lives in. And that tends to be a way that can be a big problem. So by doing this, by saying that we're not interested, I'm not interested in my previous one, my loan application, about necessarily where the customer's address is. I mean, I probably am actually because of a bit of credit check, but there'll be loads of bits of information about the customer that I'm not interested in. So I don't need to get those. I don't need to get them. I just get the bits of information I'm interested in. So we're keeping it contained. We're not reusing. We're actually looking at what we need when we need it. And then we're keeping this process. We're keeping this thing that we're going to input something into our process. We're going to process it. We're going to do something with it, and we're going to output it at the other end. Now those inputs can be a synchronous call. They could be a response to an event. They could be a promise. It doesn't really matter, but they're an input into the system. And outputs again could be a straightforward value. It could be an event, or it could be a fulfillment of a promise. But the basic thing is that we do this process. Yeah. And this actually gives us a lot more freedom as well. So when we're dealing with our balance inquiry, it's very simple. We're dealing with our 3 layers there. But we might look at a NoSQL. I just did that at random. A NoSQL DB just to show a difference. Our transfer money might rely upon an API call, business layer again, using an ORM to our main DB. And our loan book report, maybe using a BI at the top end, a business layer through to SQL, and a reporting database that may be separate from the NoSQL database. So what we're saying is that within our objects, we may have those layers again, but they don't have to be the same. We're not reusing our technologies here. We're using the technology that fits with what we want to do at that moment. So you've seen that screen. So here are our vertical slice architecture. We have our domain-specific functions, our domain-specific objects that do specific things, each one separate. We have our cross-cutting concerns that sit over the top of it, validation, authentication, authorization, for instance. There may be others. These are the things that will happen possibly before these cases, or before the application starts, the process starts. So we would go into our balance inquiry via these cross-cutting concerns. And they are domain agnostic, sorry. They, can't say that word. They are something that we will always do wherever we're doing it. And then at the bottom we have our persistence. So our structure becomes slightly different. There was another slide which I took out and I shouldn't have done. So what our main thing here is when we add a new function, we are adding, not changing. So if I add my new feature in, it doesn't affect any of these. It doesn't affect any of these ones here because we're adding to it. So that means our merging isn't affecting anybody else. It doesn't impact on anybody. We're just adding to our system. We're not changing. So we're distinct merging. We don't need to merge our objects with people working on a different system. So if I'm working on a balance inquiry and Alex is working on a loan application, we don't tread on each other's toes. We can isolate our testing, because again, I'm not interested, if I'm testing a loan application, I don't necessarily, it shouldn't impact upon my balance inquiry, so I don't need to test them both. And it's a simpler system. We don't end up with all those things all over the place. I've got 5 minutes. I'm running ahead of time here. So, okay. So, yes. I'm going to go back a slide actually. I've got a few seconds. I'm going to go back. Ooh, that's the wrong way. Do you want some code? You can tell I've done this before, can't you? Right, okay.
What was the code after the Q&A?
Because I wasn't sure about actually showing code. That's
the answer to one of the questions.
You planted it.
Okay, actually, no, let's go back to the code. Let's go back to the code. Let's go back. Oh, wrong way. This isn't. Oh, come on. Okay.
Too many transitions.
Right. Too many transitions, yeah. This is too far too small, isn't it, for this size screen? For this.
Is that Java?
It's TypeScript.
Oh.
I tried to go for something agnostic. I spend most of my time programming in C#, but I thought nobody here will want to look at C#.
I like C#.
I like C#, but nobody wants.
And I run it, so what I say goes.
Because there's too many open source people here. Anyway, so I did this in TypeScript. So this is what I mean about, and this is a fairly uniform way of approaching something. If anybody's done patterns, this is looking at this is a mediator pattern. So to go through this quickly, very quickly, I promise you. So we have our loan application class that has a handler. That extends our handler, which is a generic class, and it implements a method called process, which takes an input here, our loan application input, which is an object. And returns an output, which should actually be, yeah, that's right, sorry. That actually should be an interface, but okay. So it returns an output, does some processing, it might do our cross-cutting concerns up here, some of our cross-cutting concerns at the beginning, and then it creates our output object and returns our output, and these are our two objects, so our input object and our output object. So you can see that we can do a lot of similarities in this, because everything extends the same objects, these inputs and outputs. We can do some things with that, and there's actually there's something I use in C#, and there is a TS version of it called mediator. I think that's spelled right. Because it came along at that time when you couldn't name a project without losing a vowel. So this is even smaller, I'm sorry, but the basic premise is the same. But this implements this interface, which does some of the heavy lifting for us with the mediator, with the mediator pattern. So again, we have our response and request. We have our handler in the middle here. The difference being that we can then just use this mediator, and we just send it a response, and it comes back with send it a request. I should say request, it says response. That's what comes just typing and not doing any checking. That should be loan request. So we're sending it. We send it a type, and we get back a response based upon that type. So we don't have to do any of the other stuff. As I say, the advantage of this is it gives us a common way of dealing with things, but at the same time, it encapsulates all our logic within this thing. As I say, this is not an enterprise solution. I wouldn't advise you doing this on an enterprise basis at all. There are better solutions in those environments. This is for medium-sized projects where we wouldn't necessarily want to be implementing microservices and the complexities that arise from that. And then I will stop and say questions. And I'll do that in a different order. I spent ages ordering these slides and then I just completely reordered them on the fly. Anyway, so, yes, I'm finished.
Any questions?
Yeah.
Oh,
Yes?
always you.
Always you.
That was really interesting, Bill. Thank you. I never get a chance to play that with this sort of stuff, so yeah, I was widened. Probably a stupid question, but it feels really logical to have those vertical slices. Why wasn't it always like that?
I think it was to do with this idea of separate. There's a couple of things I think, but there was an idea that we separated this separation of concerns. This idea, this is a term you'll hear sometimes in computing, that you are separating out things that are broadly the same. So the idea is that your business logic is all broadly the same. So we'll lump it together. And also, it also sort of fitted with some of the infrastructural architecture at the time. When I was first building these sorts of systems, for instance, the database, obviously, the data layer was a centralised database, whereas these would all be sitting, and then these would be desktop applications sitting on somebody's computer. So the business logic and the UI would often be a single program sitting on somebody's system. Or we had this thing, this horrible technology, because I was working in the Windows world. Does anybody remember DCOM? Yeah, DCOM was basically DLL hell on acid. The idea was that your components, your business logic, for want of a better word, could sit on a separate server, and you could interact with those from your desktop application, and that they would then interact with the database. So there was a certain amount of logic there that we were separating out. We were separating out similar items. And as I say, there was this weird idea that we might actually want to change our database. As I say, I've never actually come across a situation where that ever happened. But there you go. That was. I remember being taught that. And the same with and you've got to remember in those days as well, user interfaces were a completely different thing, in the sense that we were building Windows applications often, and either using Windows Forms or a little bit later Windows. What was it called? I want to say WCF, but it wasn't WCF. That was something else. Anyway. And we weren't actually at that point dealing with websites, so there wasn't necessarily that physical abstraction. But yeah, sorry, that was a long-winded answer to say I don't know really. That was just to perceive wisdom. I think it was to do with this idea that things that useful things or similar things, so we'll group them together. I'm scared you're asking me a question as well, aren't you?
Me.
Yes, you had the word solution architect in your title.
Yeah, sorry. Feel free to say shut up.
No, please do.
You're allowed one veto.
Yeah. I'm interested when you talk about that idea of these, when you're requesting the customer data, you only want certain aspects of it, and the customer object might be huge and will grow over time. Does something I'm sort of seeing becoming more prevalent now, but still quite small, is something like GraphQL that enables to give you that flexibility over the API call, so that you only request what you actually want, so you don't actually care how big the object is. Yeah, I can. Yes, I've used some. Crikey, what APIs have I used? There are APIs that I've used that do precisely that. You say that, but and it depends, I suppose. I've not implemented one of those solutions, so I don't know how decoupled that the GraphQL is from the object. So I in a sense, I don't know.
is the answer to
Yeah.
that. I
Just a
don't-
bit, because it sounds like it might be something that
Yeah.
sort of aligns a little bit with that approach. I think as not as a replacement, but as it could help.
Yeah, I understand what you're saying. I think the thing is, this is where this is coming from is not really within that API environment. It's more for an in process, and this is, I should have said that at the beginning actually. This is more in process, so this is something that's happening on a single server, not in that sort of environment. And it's a bit about trying to give some of those ideas about decoupling down into that sort of scale of project, rather than, because I think it's easy when we deal with it. We forget sometimes that that when we deal with enterprise level or those sorts of size projects, that there's a whole host of projects going on, things being built all over the place that are nowhere near that scale. And to implement some of those technologies on that scale is just you're using a rather large sledgehammer on quite a small nut, and you're just introducing layers of complexity, and that would be my only concern. Sorry, again, a rambling answer. You see, I'm well prepared for this. Yes.
This is where I introduce my utter ignorance. Okay.
It's all right.
I'm not a programmer. I tend to pay the programmers and observe. I'm just wondering, we're just starting a new project, and my biggest concern with what we've done today has been being overwhelmed by the test process because of the interdependence of all the different features and bugs just sort of progressing down. And this time around, the guys are talking to me and they're saying it's not an enterprise application, it's smaller than that, it's going to operate on a single server. But the idea is that we're going to isolate all of the features out, everything's going to go in through an API on that single server. And what they described to me felt similar to what you were saying there, where each of the features has been developed independently. We're starting with the API and all the endpoints. Then we're gonna build an array of features around that, and each of those is essentially going to be isolated through the API interface, the database, and other features. Is it similar to that?
I think that the only point I would make about that is that what you've got to be careful about doing is not just renaming things and effectively ending up with the same problem.
Yeah.
So if you're talking about an API that returns, say, your customer data, and then building a business logic sitting on top of that does something with that customer data, then you're still dealing with an n-tier architecture. You're just replacing your data layer with an API. The way I would think about this in potentially in that, I mean, is it a web service or a website on top of that? Is to think about it really in that, if I go back, no, I won't go back to the slide because I'll get lost. If you think about that banking application I was talking about, that fits very well with the sort of SPA. Do you want to come across the term SPA?
No.
Single page application. It's a way of developing websites. Where you are issuing commands from the website itself is interacting directly with an API. So the API, but in that case what I would be looking at doing is making the API think along the lines of those features. So rather than having a business logic that says, oh, I want to create my, going back to my loan application for a moment, I want to create my loan application. So the first thing I've got to do is get customer data. What I don't want to be doing is seeing there is somebody going, okay, well, we need an API call that says get customer data. And then we go off and get the custom data, and then we have a logic that deals with that. Because all you're doing, as I say, is you're changing the names, you're not actually changing the functions. What I would want to see is an API call that said something like loan application, and then send some data into that process, and probably, and again, I would send in, talking off the cuff here, I would be talking about sending in objects rather than sending in particular calls. So your payload would be a JSON object, effectively, that described that describes your loan application, and then the other thing you've got at the end is a JSON object, obviously, again, that describe the outcome of that loan application. I wouldn't be worrying too much. If I want to go to customer data, for instance, then I'll be looking at that from the point of view of what do I need that customer data for?
Yeah.
So am I looking at, am I just displaying the customer details for the customer to see? In which case, this is the data, the slice of the data you want. Now, you may be able to see something like the graph API and say these are the bits of information I want. But in your environment, you might find that it's a bit of an overkill in the sense that you could just have three different or four different ways of getting customer data depending upon what it is you want. Depending upon, as always, it's there's 100 answers depending upon, and it all depends. It depends. that classic engineering. Oh yeah, no, but it depends. Anything else? Yes.
I was wondering, would it actually be quicker to do it your way, or would it be a save in terms of actually the memory processing, so if the clients want it, because it's easier for them to do it, just with budgets like that?
It could be quicker. It really, I mean, it's like anything else, isn't it? It depends upon where your bottlenecks are. If you're doing something that is, your advantage can be, going back to our API example, that you end up with a less chatty interface. So you end up with, I send some information, I get some information back. When you have, if you have a more broken down interface, you're doing that, and often you'll find that your points of slowness are not necessarily within code, where a piece of infrastructure is talking to another piece of infrastructure, because obviously you're then reliant upon the speed of communication between the devices. And that's less of a problem than it used to be, because it's somebody else's problem now. It's AWS's problem, for instance. In the old days, when it was down to your ops guy and physical cables, so those sorts of considerations were a big deal. And also, we're often these days, obviously, talking about virtual boxes anyway, so you know they're not necessarily physically separate in the same way. But you've got to know where your bottlenecks are in your code. What is it that's causing you grief? Is it because it could be right down at the bottom end layer of is your database properly indexed? Are you using a database when you should be using NoSQL? That sort of thing, right the way up through. Is my database queries optimized right the way through up to? Is it because I've got an API that there's 100 calls between the client and the API just to do one thing? You know, so there is no simple answer to that. But what you can do with this is it's a lot easier to measure it, in the sense that you can say, well, this is like call, this is an input, this is an output. We can see how long it takes. So your metrics, you can put metrics on there. Sorry, you're going to get long-winded answers out of me if you ask me questions.
I feel bad because I'm really in the toilet.
No,
Anyone else have any questions? I don't want to prevent anyone. No?
He's not giving us one more.
Yeah, all right, one more.
One more.
Oh,
Just to
I'll
make
hold one
you
more.
feel free to go.
Just to
yeah.
Alex's ladder.
I'm interested. Does, and I think to your point around the testing side, does this approach make test-driven development easier or more difficult, or is it completely separate?
Yes and no. It's harder in the sense that you're potentially doing more in one thing. You know, there's a lot more interaction going on in there when you're doing a test. If you're talking about just doing a test on the outside, I mean, obviously you can within that you can treat it like a mini application, and you can expose interfaces so that you can get down lower level to test. But yes, you're testing a bigger thing, so that may. But what you are doing is testing something built in isolation. So what you know is that if that fails your test, there's something in there, and it's not something something somewhere else, and so it helps your testing that way. But it's like a lot of these things. It can be double-edged, and I would always say that testing is an interesting one. Alex was saying earlier on about repos and about do you source control your code? I'd say that the one that my guilty admission is probably I don't build enough tests. It's boring. But yeah, so it's to do with complexity. So if you're dealing with something that's really complex, and there's stuff within this technique about pushing things up to the domain model anyway, if you in certain circumstances. So this is a very brief introduction. There's a guy called Jimmy Bogard who came up with this concept, and he blogs about it a lot. And you'll notice that some of the slides might look a little bit similar to his if you go and look him up. But yeah, he talks a lot about that. He talks about how you can do it with looking at code smells to push things up to the domain level, which would have an impact on that testing as well. But yeah, it was just yeah.
So how does it go against? It sort of goes against a lot of the dry principles, doesn't it?
It does go against dry in a sense, but the argument is that how often are you actually repeating yourself? This is the code. I mean, to use that example I was saying earlier on about a mortgage application and a loan application, but you could argue that it was similar. So they're so similar that they're the same thing. So we'll just do the same thing, and we'll just put some parameters around it so that we can reuse our code. But if you're not careful, what you end up with is then lots of if statements and lots of case statements and things to deal with the fact that you're actually reusing the code. So what are you actually, are you at the end of the day, just because sometimes copying and pasting and just having it in two places is actually easier than saying we're never going to repeat ourselves, we're never going to do it twice. But yeah, it does fly against it. It does fly against dry.
I would dispute the fact that I personally would never go down your principle.
Oh, okay.
Because I think it goes against everything that I, as a developer, believe in, that you should do. You shouldn't do things twice. You shouldn't. I think it adds to your technical debt. If you've got a problem with something and you've replicated it in several different places, albeit slightly differently, I can think of several utility functions that I've written, for utility methods and things, which are used throughout the application in all different things. It's that sort of thing. You could say, just palm it off into dependency and inject it that way. But I think.
Well, I think there is a distinction here. I think if you're talking about the there are things that I group there as domain agnostic, and there are things that I wouldn't write logging code, for instance. I wouldn't rewrite my logging code every single time. I would inject some logging. I would inject a logger and use that. So it's not that you don't ever reuse, but what we're talking about is this distinction between things that are pure reuse, that we're going to do. Logging is the same wherever we do it, for instance, and something that looks the same but isn't quite the same. That's where I would draw a distinction between those two things. And you're right. There are definitely utility things that I wouldn't rewrite every time.
Okay. So there's a bit of a blurred line then.
There is a blurred line. Okay. Yeah, I was talking specifically, as I say, about features, and this is what I meant also about pushing things up to the domain, which I didn't go into in this at all, which is when you might have something, because an example, sorry, can I? Yeah. An example was something where you wouldn't want to rewrite something more than once. It might be something where you had a business rule that was hard and fast, and you didn't want to get a complex rule that you didn't want to get wrong ever. So, for instance, the way you calculate compound interest might be something that you want to write that once, because you do not want two different systems coming up with slightly different answers because you've rounded numbers differently in the two different systems. So there are exceptions to this. Don't get me wrong. It isn't like everything else. It isn't a blanket. it isn't blanket, but it was more about getting a flavour for what we're doing.
They put it like that, it sounds a bit more feasible. The original plan, I was
Fights
like,
off.
whoa.
Yeah, well, I mean, as I say, it's an attempt to do something. It doesn't work for everybody. It doesn't work for anything. And I wouldn't say there was a single way. I'd never say there was a single way of architecting a system. There's always dozens of different ways, and some of them are equally as good. They're just a different.
Right, on topic there.